Hello, good evening, everyone, and welcome. We have entered the second month and are truly midway into the GenAI Exchange Hackathon, which is an initiative that aims to use AI to unlock business and societal opportunities for India. We also want to show that AI doesn't just exist on paper with a few big companies, but rather is used well and used by all developers and startups in the India ecosystem. In this journey, we are also partnered and supported by the Mehta Startup Hub as well as by Startup India and a host of other partners. This initiative actually brings together developers, enterprises, ecosystem partners, and the idea is also to empower participants with knowledge, tools, and mentorship. You have seen that through a series of talks, etc. And we also want to thank Lightspeed for our valued partnership on this initiative, which brings me actually to today's talk. The talk today is very exciting. I'm happy to host this talk along with Romit Mehta, who I'll introduce in a minute. The title is Success Stories and Lessons That We Have Learned from GenAI Investments. And who better than our VC partner, Lightspeed India? Before I get to that, just a very quick introduction. So Romit, welcome, Romit.
Thank you.
So both Romit and I will lead the discussion here. My name is Harsh, and in my current role, I lead the APAC partnerships for research and core and AI. The heart of AI innovation being Google DeepMind and Google Research at Google. But essentially, I've spent the last 18 years in and around corporate research. So I have seen the evolution of AI myself, from computer vision and embedded systems in the lab to AI as a memory system, what we used to call Watson in IBM research, to AI on the edge in Microsoft Azure. And today in 2024, for the last 2 years that we have seen Gen AI take over the world like nothing that we have seen before. So with that, that's my introduction. Romit is my partner here who will chat with me. And Romit is the VP at Lightspeed India, which focuses on early stage investment at the fund. Romit has a lot of sort of investment hypotheses, but before we get to that, Romit, can I invite you to also introduce yourself to the rest of the audience?
Hey Harsh, thank you for having me over, and I'm really excited to speak with you about lessons that we've learned while investing in AI. As I mentioned, I'm a VP at Lightspeed. Among the areas that we spend time on deeply at the fund, and I co-lead is on vertical AI applications and AI services. That's been an interesting area for us to explore from the fund side. 4 years at Lightspeed, 2 years at a private equity, growth equity fund prior to that, an early part of my career in consulting and operations across India and Africa. Pleased to be here and chat more about all that we've done at Lightspeed.
Awesome, Romit. Thank you so much. So it's a perfect VC and with a focus on AI. I think what better could we expect? So great. Let me start by, I think you've been a VP here. You would have come across hundreds of AI companies, maybe annually, you would know the number better. Let's start by understanding what do you generally see in these companies from an AI point of view? What's your high level hypothesis to, let's say, the wheat from separate the wheat from the chaff? So what's your hypothesis there?
Yeah, absolutely. That hundreds of numbers, absolutely correct. We were doing a tally internally, and we met about between 400 to 500 AI first startups in the last 12 months alone.
Wow.
It's crazy, more than any other space that exists in our work. And that clearly sort of tells you about, how much is getting built here. But to Harsh answer that question, let me sort of talk about Lightspeed globally, because we're a global platform, and then talk about Lightspeed India. If you think about Lightspeed globally, I think the first generation of startups in some sense were at the infra layer, right? That model LLM layer that we saw globally as a fund. That was the time to make those investments, and we made numerous of those. So some of our investments were Anthropic. We invested in Mistral in France. We invested in Sarvam in India. As those layers got built out, obviously, the the models became more sophisticated, and the time was right to build applications on top of it. So actually, of that 400 to 500 startups that I spoke about, we met last year, about close to 65% of them were actually on the application layer. So that has been the dominant space where we're seeing startups emerge. And even if I cut it by application layer, there's vertical application and there's horizontal. We're seeing more and more of vertical use cases emerge as founders sort of get sharper about the problem statements that they want to go after. So that's the kind of broad lay of the land that we've seen. Traditionally, India has been an application-heavy market. So while our counterparts in the US saw, a few more infrastructure layer or LLM or model foundational layer startups themselves, we have seen a lot more of application layer startups, and now also seeing more of AI services startups.
Mhm. Amazing. That's a very beautifully crafted thing. And so you said you started with the infra layer, went on to the application, and then you're seeing also AI as a service. So that's an interesting evolution. And wow, those names like Anthropic and Mistral and now Serverm in India are truly exemplary in the infra layer. So I think some of the other names that we know from India ecosystem like Yellow AI, Rephrase, and Pepper Content, some of the companies, in fact, Google also works with. So it's the same ecosystem. I do work with some of these companies. Could you also shed some light on after the initial rounds of some of these companies which started in India? Uh, how have these companies, like actually the successful ones, progressed versus again, as a VC point of view, there might have been a hypothesis on 10 and I don't know, maybe three, four of them would have been successful. So again, what you see is contributing to the success of some of these companies that you have invested in?
Yeah, I think so. What's interesting to note is that the startups you've mentioned, Yellow, Rephrase, which is now acquired by Adobe, and then Pepper, all of these were
Yes.
investments that Lightspeed had made prior to the Gen AI wave, right? So these were trying to solve a problem in Pepper's content. In Pepper's case, they were trying to be the content marketplace for large companies. Yellow while going after customer support. But all of these things were being tackled pre-Gen AI, right? What Gen AI has
Interesting.
fundamentally, yeah. So in some sense, they were, obviously, I don't think anybody saw the Gen AI wave coming in the way that it did. But the bet was that things would get more automated, and there is a way to perhaps augment the human and improve their productivity. So that broad trend line, I think, we caught on to pretty early. We obviously, like everybody else, were taken positively by surprise in terms of how much that human capacity has been augmented because of AI. So what's that led to? What's that led to is dramatic reduction in cost structures, right? So that human throughput, which is important in some sense, these are marketplaces, right? A Pepper content might connect a large enterprise with somebody to create content for them, which could be SEO, marketing collateral, whatnot. That productivity of that supply side is essentially shot through the roof, so that one person can now do a lot more work, which sort of which they would take a lot more time to do earlier. What that directly impacts is the margin structures of these companies, right? So that sort of led to that direct impact. But even if I zoom out, I think one of the things that we do regularly, and also through our investments, is we kind of look at where is the compute capacity of these foundational layers going, right? Where, like, foundational models going. The two areas that have been actually very interesting to us have been healthcare and BFSI. We're looking at large companies, coming. We foresee a lot of companies coming out to serve this segment, and I'll maybe talk about just a couple of them. We invested in this company called Triomix, that is essentially helping large pharma with better, cheaper, and faster drug discovery, while ingesting sort of all the previous data testing data that exists out in the market, right? It's founded by two founders. Now they're sort of selling in the US. The other company that we have invested in globally is Abridge, which essentially makes sense of unstructured data that happens in a hospital setup, in a clinical setup, and essentially transcribes that into clean medical notes for a clinician, right? Which sort of helps them with automatic uploading to the EHR system faster turnaround time with the insurers, etc. And it really cuts down a lot of manual processing work that was done. So broadly, if you sort of look at it, our thesis on healthcare was that, or why we've been investing behind this trend line is that in healthcare, the rate of data collection till date has far outpaced the rate of data synthesis just because there was so much data. What AI will fundamentally change and is fundamentally changing is that synthesis layer is catching up, and that's a very interesting trend line. So that's the kind of sort of forward bets that we take and we invest in. And yeah, hopefully now companies can be created with lower cost structures, as I mentioned, and so they turn out to be good investments.
Absolutely. No, I think very good points. Kind of the AI data being produced with the human in the loop, augmenting further AI. So
Yeah.
just I think the examples you took from health, or for example, Pepper Content, we actually work with them on the multilingual aspect because they produce very high quality multilingual data, which again, as we know, is not there. So if you look at the Indic languages, the long tail Indic languages, there's not enough data or high quality data on the web. And again, to feed the models or to improve the models, ultimately we need that data set. So this is amazing thoughts. Maybe we could double click any thoughts. So we discussed the infra layer, we discussed the application layer. Any thoughts you would have, you could take up sort of a specific example or just hypothesis on the data transformation. How you have seen data, whether it's sort of pre-training, but more in the post-training stage, which these companies use, or any company which is actually just focusing on the data layer as such. Uh,
Yeah, I think Harsh, our view internally is that it is still early days for that.
okay.
If you sort of think about, I guess, the application layer wave in Gen AI, it is perhaps 18 months old, if not less than that. We
Okay.
just think that it's too early for large outcomes to get created there. What we have seen is a lot of unstructured data being synthesized to create actionable outputs at a much lower inference cost and at a much faster capacity than before. But for like true RAG model companies to emerge that could do that data pipeline transformation well, it's just simply too early in the ecosystem. So hey, we're on the lookout for that. If somebody's doing that, please hit me up. But yeah, I think it's a little too early in that ecosystem journey for that.
Makes sense. Yeah, definitely.
Yeah.
Thank you. So I think thanks for that sort of hypothesis on the market potential, the companies that you have seen. But again, as an investor, I'm sure you can never escape the funding questions.
Yeah.
We know, especially now, this also brings me to the point that while you have looked at a lot of these companies, the hard truth in the startup ecosystem, at least from the numbers that we know, is that the H124 funding in AI startups was down and significantly down. Now, there is maybe something that we know we don't know. And that's why sort of my next question to you is, how has been your approach in investing? Sort of what have been the lessons that you have learned from previous investments that are currently influencing your investment strategy in this space? And maybe also if you can share your view on, there was a article I read somewhere that look globally, especially in US, the AI investments have been going up, whereas in India it's down. And recently, I was at this FICCI conclave where somebody used the word which I didn't fully resonate with. They said, "Oh, after the initial euphoria and hype, now it's sort of died down or stabilized." So, just want to get your candid thoughts on that.
Yeah, I think that's the beauty of statistics, right? It sort of hides more than it shows, or you could sort of interpret any data anyway. I suspect what might be behind those trends is that in the US or in previous years, people might be accounting for mega funding rounds that have happened at the foundational layer, which have tapered down. I mean, Grok did happen and super intelligence SSI did happen right now recently, but I suspect those trends might be playing out, and the amount of funding required to train a data foundational model is significantly higher than what any app layer company would consume. So I think the right metric to look at would be the number of startups invested rather than the actual dollars invested, because it might be skewed right by the
Yep.
averages. So I suspect that's going on. From our perspective, actually, to be honest, we have found that the ecosystem has really matured and is maturing, at a sort of a very sort of heartening pace for us, right? What do I mean by that? What I mean by that is traditionally, Harsh, if you look at India, we've been an application heavy market. We have not,
Yeah.
it's India's traditionally not created a lot of core infra. Now, if you look at the application layer market, uh, one of the models that I'd worked in India enterprise is that of a fast follower, which means that hey, there is a global comp out there that does it solves a particular problem for a range of client. In India, you can perhaps offer a cheaper version that does something similar or even does a better job because you do have that engineering and technical prowess to create better solutions and then go sell that, right? Or find niches in the market that global leader chooses to ignore, and you end up creating a multi-billion-dollar opportunity out of that. Now,
Yeah.
fundamentally, that is an opportunity that only presents itself to app layer startups, right? If you're building an infrastructure company, you cannot be a fast follower company. If your moat is technical, which is to say that you are building core infra, then for that product to stand up and be a large outcome, it has to be global best in class. So I'll just take an example. We invested in Sarvam. Now, Sarvam, we did not invest in Sarvam because we thought it would go and win against OpenAI or it would win against Anthropic or Google Gemini or whatnot. We invested in Sarvam because we thought it was the global best in class product for Indic languages. So it solved a particular thing and it solved that particular thing really well. But that's not what is needed in an application layer company. In an application layer company, you need GTM chops, which basically means you need to understand your go to market really well, who you could target, what is their core problem, and why can your solution solve it really well. If you sort of look at this, I think in 2022, let's say in 2022 2023, nobody was really sure on how this could evolve, right? I think you're still not sure of how foundational models sort of their sort of capabilities evolve, but things are a little bit more stable now. You sort of understand what they do well, you understand what they do not do well. Founders have a better sense of where competitive moats come from, why distribution is important, what matters to enterprises, and which has resulted in us actually meeting a range of founders who are today thinking about it in a lot more mature fashion than what they were in 2022 and 2023. And simply
Yeah.
because it was too early then, right? So yeah, I mean, at Lightspeed, great time for us. Sort of we are actively investing, and I actually don't resonate with that market sentiment.
Excellent. Yeah, and on the other hand, I resonate with the last thought that you said. I mean, being in Google, I've seen the chaotic part of 2022, 23, 24 has been thankfully more stable for even us on all counts, working both internally as well as externally with the ecosystem. And maybe I can also share examples towards the end. Maybe a couple of sort of closing questions to you before we turn it around. I think one is I would love to get your view of, you touched upon it, but let's say India startups building for the rest of the ecosystem, especially for the low resource environment like Southeast Asia or the Africa of the world. So how much of that contributes to, again, your investment hypothesis, your due diligence, or your specific criteria when you look at it, or any other factors? So,
Yeah, that's a great question. I think I'll claim in all humbleness, I'll claim that I think Lightspeed was perhaps early to recognizing this trend again in enterprise SaaS.
hmm,
We led the round in Darwin Box back, I believe, in
yes,
2016. Before my time, I joined in 2020, but I think we led the round in 2016. And the whole thesis was that as an HRMS solution, they would be priced better and would be more suited to the needs of India and the neighborhood of India, right? Like which includes Southeast Asia. And frankly, they achieved a $1 billion valuation with $50+ million in revenue, all accruing from the back of this region, right? And now, of course, they're sort of expanding rapidly in the US as well and other international markets. But all of this happened, their growth story or their early days till pretty sort of recent past, I'd say even maybe 2, 3 years ago, was sort of on the back of growth of this market, right? So that opportunity definitely exists. I mean, I think there was a factoid that went around. I remember last month that perhaps Bajaj Finance is the second largest client of Salesforce globally,
yeah,
right?
yeah,
So Indian enterprises do pay. I think the question is that yes, they need to see value and then need to sort of really customize the solution for the problems and often unique that they face. In terms of market like Africa, etc., I think what we've seen is a few startups try to explore maybe some of the more mature regions like South Africa, maybe
right.
Kenya, a little bit of Nigeria, etc. But they have not been sort of large SaaS markets yet. So maybe a little too early for that market. But India is definitely coming off the curve, maturing. Southeast Asia definitely as well. MENA is the other region, which has
Yes.
typically been a high ACV market, or rather a higher ACV market, which is perhaps quite underserved. And sort of we see founders often thinking about these geographies as well. Certainly, which was not the case a few years ago. I mean, if you sort of zoom back, it's literally sort of telling you about how the ecosystem is maturing, right? What have founders
Yep.
figured out? They figured out that the kind of customers to target, where to target them, and also figuring out that there are various ways to build a large company rather than the traditional India to US route, which was sort of thought of as the gospel way to build a large SaaS outcome.
Yep. No, it's heartening to see all these sort of trends, and especially coming from you, observing from the ecosystem. We have spent 20 minutes talking about the positives, but we would do injustice if we don't talk about the challenges.
Yeah.
So let's sort of switch gears and let's discuss the challenges. So I think again we understand AI is an AI in India is a huge sort of opportunity, and PM Modi was in US and spoke to I think all the CEOs, including Sundar Pichai, and the one thing he kept challenging them, right, was to say how can you build sort of AI for the consumers in India. So let me ask you, what are the unique challenges that you think startups face in India compared to some of their global counterparts? India being a very diverse and complex market as it is.
Yeah. Look, I mean, nobody would argue otherwise, right? Traditionally, it's been hard to sort of monetize Indian consumers if you're building something consumer facing. And then
Yep.
if you're looking at SaaS, SMB, or mid market, which is a pretty substantial segment of revenues for a lot of India to international or India to US motion kind of SaaS enterprises, that has traditionally it's not deep enough in India, right? So it creates standard monetization challenges. But I think if you take a step back, there's something more interesting going on, right? Um, Look at the history of building enterprise SaaS companies, right? Essentially, like if you think back on cloud, what cloud did was that basically large, smaller companies could compete on selling software because they didn't have to install their own data centers. They just had to write code and then be able to sell that really well. Now,
Yep.
so over the years, there's a secular trend of building or writing code essentially going live almost in a way, getting easier, faster, and cheaper. AI is a massive step jump on exact same opportunity, right? So now you could do with significantly lesser coding talent. Your marketing teams can be leaner. Like essentially, your whole org structure can be pared down because productivity has been enhanced multifold, and fundamentally, you can just go to market faster. So, what is the challenge with that? The challenge is, what I said up front. Like we saw 400 to 500 startups this year. That's amazing. What that also tells you is that there's incredible competition in the market, right? How does a startup really differentiate itself from the other one, right? Clearly, technical chops is not going to be a differentiator for an application layer startup because foundation model is a commodity today for all of them to access. So how do you really build differentiation, right? Like what allows you to charge a higher price versus somebody else? And these are non-trivial questions for an early stage founder to figure out, and that is challenging, right? And that is challenging especially in the Indian ecosystem because, as I mentioned, traditionally we have been an application heavy ecosystem.
Fair. But I won't let you off the hook on the India story, because another thing, at least sort of very important to Google and Google's hypothesis for AI, is how do we use AI for the societal challenges? Now,
Yeah.
I'm talking about some of the areas which are very pertinent, like agriculture. You touched on healthcare, but again, let's say if healthcare made available to all at the really the bottom of the pyramid. So how would you assess a startup which is truly solving a societal problem, a population scale impact, but perhaps cannot show you a 50x kind of a return in a few years? So how would you tackle that part?
Look, I think it's a very interesting question. I think it's the perhaps the first time in venture history
Hmm.
where a startup solving a population scale problem, right? By which I'm also like I also figure that you imply that this is solving for people in the lower end of the economic strata or pyramid,
Yes.
traditionally not have ability to pay, etc. I think it's the first time in venture history where a startup solving for them can also be a 50x and a 100x return, right? Again, and it goes back to what I was saying at the beginning. Fundamentally, your cost structures have pared down. Let me give you an example,
Right.
right? And this is a space where I've spent a fair amount of time on. Look at
Mhm.
look at the evolution of Indian edtech, right? What were the failure modes of Indian edtech? And the ecosystem has sort of learned an expensive lesson on that, right? The failure mode was that simply that you were too reliant on star teachers and you were too reliant on customer acquisition, right? So sales-led motion on the back of star teachers, right? Which meant
Yep.
that fundamentally, there was variance in the quality of education that a user of this edtech platform or a student received. At the same time, if that star teacher left, suddenly you had a void in the ecosystem because you were pulling in people because of that. Now, what does AI do, right? AI fundamentally democratizes that person learning. Right now, you have access to personalized, on-demand tutor that can, in real time, adapt to what your need is, figure out how to engage you, and then teach you better. And so, for example, I would not name this startup, but about 3 or 4 months ago, I met this startup who was fundamentally teaching English to low income students. Think about maybe third to seventh grade um,
Mhm.
in rural Tamil Nadu and rural Karnataka. The only thing that and now these like India's mobile consumption is of course really high. Everybody on YouTube. The founders had cracked an amazing GTM of essentially putting up content on YouTube that drove people to their website, and then where the students could interact with AI tutors and learn languages, right? Um,
Yep.
so this kind of innovation would not have been possible before Gen AI. So, and similarly for healthcare, right? Like now you can get access to make sense of so much more healthcare data. Like it could even you can speak to somebody, an healthcare assistant AI, if you will, to understand what your lab reports mean, while earlier you perhaps were not getting a satisfactory answer from a government doctor somewhere. So all of these things are transformational, and all of these things
Absolutely.
more interestingly all don't cost a lot of money, right? Because inference cost and compute cost are going down for application layer companies thanks to investments made by likes of Google. So I think that opportunity has opened up, and it's actually very interesting for us to meet founders who are thinking about India first, India centric solution at population scale.
Yep. Thank you. No, that's an amazing thought, and especially that last part sort of really resonates with me to say, that the Gen AI, the power of disruption that is there in terms of democratizing the entire thing. Of course, there are challenges, and we as Google, of course, know that the models have to get from here to there, and there are long ways to go. So yeah, I'll maybe even turn it around. So Romit, any question you would have for me from Google, and then we can obviously open it up to the broader audience. So,
Yeah, absolutely, Harsh. Look, I'm so curious. Google is clearly among at the forefront of the AI revolution globally today. Let me ask you a couple of questions. One is I'd love to understand how do you see the capabilities of models themselves evolving, right?
yeah.
So, in some sense, if I were to start broad, like in your view, when you sit from your perch inside Google, what does future of AI look like to you?
Yes, no, great question. And again, interestingly, I'm part of research, which is powering or looking ahead, what we call. So you would have heard of Gemini.
Yeah.
We work on things which is called Gemini Next. So what's really the future? Now, I think the couple of top trends. One, the trend of multimodal ground up. I think that's pretty well known to the fact that we are making sure that we are not bound by the challenges between, let's say, a text versus an audio versus an image. So we ensure that the model understanding is multimodal because that's also how the human mind comprehends things. So that's sort of the first change that I've seen in the last 1 year. The second change, again, the second and third trend are kind of related. Let me talk about the third trend, is that which is lowering the cost of training as such, right? So yes, even currently it costs us billions of dollars and lots of pre-training cycles and compute to train the models. But there are research techniques that are coming up to lower it by like 8x to 10x kind of a factor. And that's kind of required because we understand Gen AI is a guzzler. It's a guzzler for data. It's a guzzler for energy. and perhaps the planet cannot sustain that infinitely. So there are extremely deep efforts that are going on to, things like how can you do sort of look ahead, how can you do less tokens, how can you decipher or inference the context automatically that's there. And with the power of that, sort of reducing the footprint, the middle trend is, of course, again, Google has been a leader in terms of providing the biggest context window. So currently, I think it's somewhere between 1 million and 2 million, but stretching the boundaries and perhaps going up to 10 million as the context window, which means that truly, as you said, an AI tutor or a health tutor can really be based on post training of data, and no startup or no developer has to worry about looking at, sort of the pre-training side of things. Uh, it's not just, so definitely it helps the
Very powerful.
society. It also helps Google Cloud and so on and so forth. So yeah.
That's awesome. And then maybe I'll ask the last question you asked me back to you.
Sure.
What are the India specific use cases, that you think Google India could perhaps lead with, given what's happening on at the model front?
Yeah, absolutely. Again, I think I mentioned it briefly, but a personal passion for me has been about driving the multilingual aspects. And
Mm.
when I say multilingual, it just goes beyond Hindi. One, it goes to maybe even the top 10 languages and also dialects of Hindi so that our understanding improves significantly. We are spending X million dollars to try and generate that data because it's not available anywhere, and get the human in the loop curated. We are working with IAC as the academic partner and so on. So that's sort of one personal passion for me to drive. And also, coming up with things like English, for example. I'm sure at Sarvam, you would be, sort of supporting similar aspects where the Indian diaspora is unique, that we understand English, but when it comes to expression, it's obviously a mixed language that we are more comfortable with, or at least a predominant population. So how can we ensure that GenAI is really so Google India as such is a lot focusing on languages. Agriculture is a fast follow in the sense, how do we? So I call it the FFC, a field farmer crop. Billions of dollars, even in a country, in a poor country like India, are spent just to capture those nuances on the ground. And using satellite imagery and the power of GenAI, we want to bring that. So imagine a Google Maps, but for the entire farmland of India. If we are able to give that information back to India, I feel it could be a game changer for a lot of ag tech, government, as well as for the end farm. So just a couple of examples, and there are more that I can talk about. But yeah, that's very
Yeah, that'd be pretty powerful to play out, to see how that plays out. Yeah, thanks.
definitely.
Thank you,
So
Harsh. I'm happy to, let's go through if there are any questions from the audience.
yes, thanks everyone. So if the organizers can mention. Yeah. So Romit, there's a question for you. I think they're asking that you mentioned health tech and BFSI. So let me repeat the question for everyone's benefit. That you mentioned health tech and BFSI. Do you have examples of a fintech company that has successfully transitioned from inception to a public entity? Okay. Uh, any good examples of that?
Look, none in our portfolio. We've invested in Razorpay in India, Stripe globally, and then a bunch of, I guess, large private outcomes. But none of them have gone public from our portfolio. But we do have an example of a successful fintech that's gone public, which is Policy Bazaar, or PB Fintech, as it's called. And actually, I'm not sure what's happening at their end, but I would not be surprised if today a lot of their backend is extremely automated because of AI. And given that was the largest cost structures, their cost curves would also look extremely compelling. Yeah, I mean, I don't. That answers that question. So yeah, I
Yeah,
mean, none from our
I think
portfolio pretty soon.
no, I think so many of us use Razorpay, and even if it's not gone public, it's such a important step in the payment cycle across so many platforms. So kudos to you. And then I think the follow-on question is like, what are the, like broadly? I think the question is more broad. What are the potential challenges that you see if a company is unable to scale? So that's a very interesting question that we didn't touch upon.
Yeah. Um, Look, if but I'm interpreting this question as, what are the reasons a company is unable to scale? Look, I think there can be multiple, right? Typically, what I've found, if a company is unable to say to scale, is, broadly, I think it's just in two buckets. One is that the problem that is being solved by the company is just not pressing enough for the people or for the target market that they're solving for. That's one. Or the second bucket is that the product is amazing, it solves a real need, but for whatever reason, the company is not able to find and convince the people to pay for that solution, which comes down to your GTM strategy. Which is why, when we sort of think about, and of course, with a VC, we have a portfolio. Some companies will do well, some will be unable to scale. That's the sad reality of how the ecosystem is. But when we speak with founders, especially we speak at them at a very early stage, these are exactly the two vectors that we focus a lot on, right? How do founders think about go to market? Do they have unique insights there? Do they have an unfair right to win? Have they thought about exactly who their customers are? How will they approach them? How will they open them up? That's been, I guess, one of the big learning. And the other is how pressing is the problem that they're solving. And on the second bit, to judge how pressing the problem is, typically, you would see that if no solution exists to, today, their potential customers would be hacking a particular way to solve their existing problem, right? It's just extremely inefficient and it's kind of terrible. So when you go with a better mousetrap that, hey, like this can do what you're already trying to do in a much, much better way, you find customers converting. So yeah, so that's what we look at. And that's if either of those two
Yeah.
things are not there, that's typically why we find companies not being able to scale.
Yeah, I think knowing the failure mode is extremely important for
Yeah.
the, upcoming startups, and it's a very valuable lesson that is there. Um, I think there's another question. I think bits and pieces of it you have already answered, but still let me replay it for everyone. So the question is, when it comes to investing on specifically on AI startups, would VCs look for immediate value or sort of value over a long term? Maybe some view on that.
Look, I think so. As a VC, our we're long-term partners. When we invest in a company, we're looking to partner with them for 7 to 10 years. The idea is that they will accrue value over that period, right? So let me just sort of lead with that. Now, the way a company accrues value really depends on the kind of company that is being built. So, for example, a foundation model company would not accrue value from day zero. And when you say accrue value, I'm not talking about valuation. I'm talking about actual revenues, right? Those would take time, and the idea that we are betting on is that the world will be an agentic world where you'll have multitude of agents calling up upon the foundation models to perform a certain task, and that sort of revenue model would accrete, right? Versus, let's say, if you're building an application layer company, then I think you would go after an annual plan, right? That okay, we close this year at revenue X. Next year we expect to grow by some percent. This is the contract size we're aiming for. These are the number of customers that we're looking to target, and then you kind of work with the company to make sure that they're on plan. If they're not on plan, then try to figure out why they're off plan and what can we do to sort of right the ship. So yeah, I mean, the answer is that there is no one answer. It really depends on the kind
Yeah.
of company that's being built. But in VC, it is extremely important to be patient because when companies compound, that power of compounding is magical. Um, think about
Yep.
investors who held on to Zomato after it went public at 4 or 5 billion, and today's at 30, right? So that compounding is magical. It always pays literally to wait.
Excellent. Thank you, Romit, for that. And I'm sure like the number of easy questions you get is phenomenal. Okay. Yeah, I think there's a question for me, which is about is Bodo language of Assam support available on Google yet? Okay, so let me answer. Support on Google is a very broad term. Google has so many products ranging from translate to keyboard to speech assistant. And let me answer in a short way that yes, Bodo language is an important language and there are teams working on it. How soon it will come and enable translate and speech and Gboard is something that you can check with me offline. I don't know exactly which are the ones that are live on the several Google platforms that we have currently. That's it. Cool. Maybe last one or two questions. So the question is more broad. What type of applications are GenAI are overused, and which are the ones that are unexplored yet? Uh, any thoughts, Romit? And then I can also chime in if you want.
Yeah, I think I think if I sort of were to break down that 400, 500 pitches that we saw, I think we saw a lot of stuff on sales and marketing. I still think there's space to be something to be built there, but that bar has to be really high, right? Simply put. I guess in terms of what's unexplored, look, I mean, I think there are cases that you can speak about, but I think sort of I'd encourage folks to also think about net new cases, right? Now, what would a net new case look like for an AI first world? An interesting theme that we've been spending time on is AI services, right? Why AI services? Now, these could be companies that were traditionally seen as service first companies, so think consulting, think tax audits, whatever, right? What have you, but they have an AI first workflow approach to it, right? What AI fundamentally does is that allows you to move away from a per seat model, which is how these companies have traditionally charged, to an outcome as a service model, right? Which fundamentally means that you can charge for the job done versus the number of man hours you put in. And then as model capabilities increase, the man hours that you need to complete that outcome should theoretically reduce, which means that gross margins here could look like what gross margins for best in class product companies look like. That is that's a use case that sort of happened literally because of generative AI, and it's kind of extremely unexplored. I think there's a ton of stuff that can be built there. We're in very early days of that. Similarly, I think consumer social, right? Think about personalized social media applications, personalized tutoring, all of that kind of stuff. Market completely open for grabs. It's something to explore.
Yeah, I kind of resonate with you also because of the fact that I think solving for some of the internal productivity and chatbots are like these are things that any company can do off the shelf with the kind of capabilities on cloud that are available today. As opposed to the personalized stuff or even the agentic stuff. I know we didn't talk about that in a big way, but imagine a world where there are sort of millions of agents sort of interacting with each other or interacting on your behalf. So that's another, I think, area which is coming up from our vantage point. Okay, I get a hint that we are on the last question for the day, and the question is why India's AI market is far less than US, China, etc., and what can students do? Okay, that's two different questions, but anyway, Romit, your thoughts, and then we can conclude.
Look, I mean, it's not just AI market, right? Like I think even as a venture market, US and China is ahead, so it's kind of natural. Um, it's not surprising that if our AI market is sort of not as large as them. What is, however, also true is that India has among the most vibrant startup markets globally. And given whatever restrictions exist in China, there's no reason why can't we be the number two player here after the US, right? Sort of building the best in class vertical AI companies, building AI services companies, building population scale AI companies, which would be very unique to India. And that's kind of more exciting to us than sort of worrying about the top line number, because it's literally about what problems you can solve. So what can students do? I guess what they should always do is sort of follow the curiosity, learn and take risks. That's how we get to meet incredible founders and see amazing problems being solved, which is what excites me to do my job every single day.
Awesome. Those were really good golden words to end off. So with that, I think this has been an amazing sort of discussion, at least for me. I'm sure for the audience also, it has been a great discussion. And with that, I want to thank everyone for today's evening, spending time with us. And back to the organizers to sort of close it off.
Thanks, Harsh.
Thank you, Ram.
All right. Good evening, everyone. Welcome to the GenAI Exchange Hackathon by Google, supported by the Ministry of Electronics and Information Technology Startup Hub and Startup India in partnership with startups, enterprises, and VCs. Thanks for joining us today. If you haven't registered for the hackathon yet, please find the registration link in the chat box. I hope the previous deep dive session that we had on deploying apps in the cloud was helpful. Today, we'll be deep diving into another topic which should be top of mind for almost every company today: model evaluation for generative AI. My name's Anirudh, and I'm a customer engineer at Google Cloud, and I'll be your host for today. Feel free to ask any questions that you have throughout the session, and I'll do my best to address them at the end of the session. All right, so let's get started. So I think the first thing that we need to understand to um, figure out what our strategy should be for generative AI model evaluations is to figure out what we have traditionally been doing with traditional predictive machine learning, and then understand why the traditional predictive techniques do not work well with generative AI. Then I'll cover what are the techniques that are specific to generative AI that we found to work well, and finally conclude with an overall view of what the landscape looks like today. So if we look at how model evaluation is traditionally done with predictive machine learning, most production level machine learning flows have uh, uh, so-called MLOps pipeline in place, right? So you do your prototyping, then you run experiments on your prototypes, then you have a production training pipeline, then you serve the model, you do some canary and A/B testing, and finally, once the model is deployed, you're going to monitor the performance in real time, right? So, and within this cycle, if we look at where model performance or model evaluation really comes into picture, it is in three major steps. Initially, when you are training your models and evaluating models to decide which one needs to be deployed, you will be looking at certain metrics during your experiment comparison phase. Then, once your production training run is done, you will be looking at specific metrics during the canary and A/B testing phase. And finally, once your model is actually deployed into production, you'll also be looking at real-time metrics to make sure that the model is continuing to perform well throughout the production training cycle. Traditionally, we look at metrics like accuracy, F1 score, RSA, OEC, etc. for evaluating experiments, that is during the model selection phase when you're training the model. And once the model is being deployed into production, either for an A/B testing or in real-time production, we look at metrics like drift, skew, and specific business metrics that are being satisfied for continuous evaluation. Now, this works really well for traditional machine learning, but where it really breaks down for generative AI is, firstly, the biggest difference is that most companies are not training foundational models from scratch, right? So a lot of these guidelines which work really well for training models from scratch, they are either not necessary or not applicable for people who are actually fine tuning existing models or adapting existing models for new use cases versus training them from scratch. The second major difference with generative AI is that the input and output domains are practically infinite. So essentially, your input domain and your output domain, let's say for a large language model, is the entire corpus of possible text inputs and outputs, right? Which is a huge domain. It is not similar to your traditional machine learning where you have a fixed set of inputs and a fixed set of possible outputs. So that complicates our testing strategy slightly. The third key factor is that generative outputs can have multiple correct answers, right? So if you have a large language model that is generating a summary or generating an answer to a question, right? The contents might remain the same, but the exact words used or the exact phrasing of the answer may change between invocations. And while the answer remains the same, it is not as easy for us to test it, like how we do with predictive ML, where we have a single ground truth label that we compare against. And finally, when we zoom out and look at the larger picture, very few companies are using large language models or generative models by themselves in production applications. More likely, what you're doing is you will be using it in a system or with an architecture which includes components such as retrieval augmented generation and function calling, which would need to be evaluated both separately as well as together with the entire system. And that adds another layer of complexity which has not been dealt with in traditional predictive ML before. Now, some of you may be thinking, yes, we do understand the complexities of evaluating generative models, but there are a bunch of leaderboards that are available online. I'm sure you've come across a few, which seem to comprehensively evaluate these models based on different factors. So why can't I just take a look at a leaderboard and choose the model that's on top of the leaderboard, or choose a model which seems right to me according to the leaderboard? The major challenge that we have seen while working with customers in productionizing these models is that there are certain flaws in leaderboards are not which do not make them suitable for directly using them in a production setting to evaluate models. The first major point is that they use these specific narrow academic tasks for evaluation. Things like your GSM 8K or your MMLU benchmarks are great academic benchmarks because they evaluate the capabilities of a model in a specific controlled way. But when you extrapolate that to your production use case, very likely it is not similar to what you will be using it for in your use case. So that skews the results a lot because, as you know, LLMs are capable of a wide variety of tasks, and their performance on this wide variety of tasks can vary greatly. A model that is doing really good on one task may not be doing as well on a different task. So, making your decision based solely on the performance on a particular benchmark may not yield the best results. Another key factor is that there is no normalization on these benchmarks for inference techniques. Now, what do I mean by this? Over the last year, there has been a lot of research, not only on building these foundational models and the architecture of these foundational models, but also on identifying what are the right ways of using these foundational models to get the best performance out of them. So the key factor here is we've identified different methods of prompting or different techniques of prompting which yield better outcomes. For example, some of these patterns that you may have heard of are things like chain of thought prompting, things like self-consistency, right? So that there are a lot of these different patterns of prompting that have shown to yield better results. The catch here is that these patterns, or at least some of these patterns, may either require more compute, longer time of inference, or both to yield these better results, right? And these may not work with the particular setting that you want to use the LLM with. Comparing, let's say, single shot inference where you have no context and you have no multiple attempts to get the right answer, versus, let's say, a self consistency 5 shot chain of thought, multiple examples provided, right? It is disingenuous at best, because you have a lot more context provided to the model in certain cases, and you have a lot higher cost as well as inference time for getting those outputs, right? So evaluating that cost accuracy trade-off is something that you will have to do by yourself without having to rely on a leaderboard or a benchmark for that. A third key factor that is being discovered quite recently is that in a lot of cases, it is found that the test data for these benchmarks that these leaderboards are using have been leaked into the training data of these large language models. Now, it may not be on purpose, but things like discussions about these leaderboards, or forum posts which have sections of these leaderboards. There are different ways in which this data can leak, because the volume of training data that these models are trained on is practically very huge, right? So there are different ways in which this leakage can happen, but at the end of the day, the fact remains that there is a lot of proof that for a lot of models, these benchmarks essentially have their test data leaked in the training set, which means that these models will perform better than expected on these benchmarks, but that increase in performance on benchmarks may not translate to your real world performance or performance for your specific tasks, right? So considering all these factors, the question remains, what is the right way to evaluate generative AI, right? What is the technique that we need to use to make sure that a model is right for us? The way I would think about this is breaking it down into essentially three tasks or three considerations. The first important factor is you need to evaluate the generative AI model for the specific task that you have in mind. Right? This is the main reason why we cannot use leaderboards, because the tasks are not specific enough to our use case. So we will have to design an evaluation, or use a combination of different evaluations which will accurately reflect the performance of a model for our particular use case. The second important factor is to evaluate the foundation model in context of your application. What does this mean? Now, as I mentioned earlier, most companies or most use cases do not use generative models by themselves, right? These generative models are a small piece of a larger um, workflow, or a larger pipeline, or a larger architecture that is yielding the outcome that you desire. So it becomes really important to not only evaluate your model by itself, but also evaluate it along with these different components. A lot of times, for example, in context of retrieval augmented generation, we found that when you evaluate the overall system, it may not be performing as well, but evaluating the model itself yields good results, right? So then we are able to pinpoint that the issue is not with the model itself, but rather with the retrieval process, and we are able to focus our efforts on improving that. So evaluating the overall workflow versus evaluating the model itself becomes really important in giving you a benchmark that is relevant to your particular task. The third key factor is automation. Right now, as I mentioned earlier, a lot of our a lot of the processes that we use for traditional machine learning kind of break down for generative AI, mainly because we don't have one single ground truth label, which is the assumption for predictive models. So we need to adopt different strategies to automate testing on a golden set of inputs and outputs, and figure out how we can actually accommodate for these minor differences in output and still figure out what the correct response is, or how the model is performing on a test set. Now, with this in mind, let us actually look at what are the different ways we can compare two different models, or what are the ways in which we can evaluate these models, right? Normally, we think or we categorize generative model evaluation into two different strategies. The first one is a point-wise evaluation, where you assess the performance of a model on a specific task. So this is essentially equivalent to taking the output of a model and scoring this output based on various parameters. Now, how would you actually score this? There are different strategies here as well. Number one, there are multiple computation based metrics that are used in academia to evaluate the quality of an output. For example, some that you may have heard of are the blue score, Rauch score, etc. Right? So these are point based metrics that are that can be computed on an output of a model, which gives you a quality score for specific tasks. Another common way that we have seen many companies adopt is using an LLM as a judge to score the output of a model on various parameters that you can configure, right? So now you can have a model where you provide your evaluation criteria for your task in natural language and have the model actually score the output of another model or even the output of the same model on these various parameters. This is another strategy that we have found to work well. And a little later, I'll also cover what are the sort of risk mitigation strategies and what are the specific approaches that we use to make this a little more robust and useful. The second strategy that we normally adopt is pairwise comparison of models. So here, instead of assigning a particular score to a model, we will provide the outputs of two different models for a given input and figure out which of those outputs are better. And once again, here we make use of LLMs as evaluators, right? Where you provide the output of both models to an LLM with some context on how to score or how to compare these two outputs. And based on that, we can figure out which model is performing better for a majority of our outputs. Now that we understand, what are the different strategies that we can use, we come to the most important part of this. How do we actually scale this out? How do we automate this? And how do we execute this at scale for our use cases? And this is where we need particular tools that are designed to evaluate large language models or generative models specifically, which account for some of the differences that I mentioned earlier. The first tool that I'd like to highlight here is called LLM Comparator. Now, LLM Comparator is a tool that was designed by the people and AI research team at Google. And this is open source. You can find this on GitHub. You can use it yourself. And essentially what it allows you to do is it allows you to compare the outputs of two models along various dimensions, right? You can categorize these inputs based on different categories that you define. You can filter outputs based on specific keywords. You can filter outputs based on specific semantic meanings. You can look at the similarities and differences between two models. And of course, you also get model scores, which allow you to decide whether a particular model was deemed as better than another one. Right? And I'll just take a moment to show you this particular tool in action. So here I have the public instance of LLM comparator with some sample data, right? And you can see that essentially for each input, I'm able to look at what my outputs are. We're comparing two different versions of the Gemma open source model released by Google. And essentially we're able to see the outputs of both these models, as well as some of the similarities that are highlighted between the outputs of these two models. In the score section, we're able to see which model is deemed to be better. We also get a rationale. Why was this model deemed to be better than the other one, right? And alongside this, I can also look at some custom metrics which are relevant to me. So in this case, I have defined toxicity and harmful content as these specific additional factors, and I can view these alongside my model outputs. Now, one of the key factors here is that many LLMs have different biases. For example, some models may have biases for longer outputs. Some models may have biases for outputs generated by the model itself. So we need to take into account these biases and figure out how to mitigate these biases. So one of these strategies to mitigate these biases, if you look here, is the score that we are getting is not just based on a single model. Rather, we are using 6 different raters, right? And these raters could be large language models, they could be different models, they could also be human raters. So we can use a combination of these signals to actually come to our decision, right? Another mitigation strategy that we see, so you see there is a column called flipped over here, which essentially makes sure that models bias for, let's say, picking the first out of 2 outputs provided to it is not coming into play. So we randomly flip the outputs of the 2 models to make sure that that bias is mitigated. So these are some of the strategies that we see to operationalize these sort of scoring, and mitigate the or take into account the biases of these models while acting as raters, right? On the right side, you can also see we have some summary statistics on the model. We're able to see the score distribution, which model is deemed to be better for a majority of the time. What are the metrics according to the prompt category that I have, right? What are the different clusters that I've detected in my rationale? So all of these custom factors that are important for your use case can be taken into account and visualized in an effective way using LLM comparator. Now the natural question becomes, sure, LLM comparator is a great UI. It is, I'm able to visualize all my statistics really well, but where do I actually get this information from? How do I actually run these evaluations and get the information to load it into LLM comparator? And this is where we have a tool called rapid evaluation, which allows you to run these sort of evaluations on your model, on your prompts, on your outputs, and specify the criteria for actually evaluating these. So rapid evaluation is a service on Google Cloud, and it allows you to define the model that you're using. If you already have generated outputs from, let's say, an open source or a third party model, you can bring those in as well. You can define whether you want to use point-wise metrics or pairwise metrics comparing two different models. And you can define what are the specific criteria that you will be evaluating your model against. Rapid eval will take care of actually running this evaluation, and it will give you a nice JSON output of the evaluation results. And this JSON output actually works really well with LLM comparator. So it's completely compatible. You can directly load this output into LLM comparator to actually visualize the results, right? So these kind of tools actually help you to scale out the LLM evaluation process or the generative evaluation process, and make it repeatable, and essentially allows you to experiment at a much faster pace by comparing different models, by comparing different settings for each model, by comparing different prompts for each model, and being sure that the model is actually performing better before you promote it into production. So one common pattern that we have been seeing with some of our more advanced customers who invest a lot more effort into productionizing AI, or for whom generative AI is actually a core part of their product, is they're able to build an MLOps pipeline around these tools, such that, let's say, they're evaluating a new model. They are able to figure out what are the best settings for that model, and then run an evaluation, a rapid evaluation against the existing model that's in production. If the new model turns out to be better, or the new settings or the new prompt turns out to be better, you can automatically promote the model under test to a production level model, or you can promote it into, let's say, a canary environment or an A/B testing environment. And you can version control your production model to make sure that you're tracking which model you're currently using, which prompt you're currently using, and what settings you're currently using. So this becomes a very essentially it becomes a very automated pipeline where you don't need to put manual effort into testing it each time. This allows you to experiment at a much faster pace and figure out what settings and what models and what prompts are actually working for your use case. With that, I come to the end of my presentation. Thank you, folks. I hope you found it helpful. And I will take questions now. I don't see any questions yet. All right. I think if we don't have any questions, we should be good to close for today. I will hand it back to the organizer. Thank you, folks.